Yes, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. Before we proceed, I'll kindly like to request our members to subscribe to our channel, engage us in the comment section, and also check the links that are normally put in our description boxes for various links of other similar videos in this specific discussion. So in this case, we're going to look at the concept of entropy change and accompanying phase change. And of course, as we said, there are various phases that we're going to see in particular discussions, of course, in this concept of thermochemistry. And of course, these are going to collaboratively assist us understand various concepts that we're going to discuss under enthalpy, entropy, and perhaps the heat change. Now, in this particular case, we are going to look at the entropy change accompanying phase change. And in this case, I'm going to consider the change of substances, perhaps from solid to liquid. And of course, in that specific case as well, we can be able to consider the change of a substance from liquid to gas in this specific order. So in this case, if you consider a substance like water, it can be able to undergo these two specific transformation, and both, of course, processes are going to involve the uptake of heat in that specific sense. So therefore, as we said from our discussion on the concept of entropy, we said that entropy basically refers to as of course the stateness of a disorder. So there's going to be increase in disorder as this specific phase changes from liquid to of course solid to liquid for water, and then from liquid to gases respectively. So we have various names that we're going to refer to these specific processes. And of course, just like changing from a liquid to gases, that is vaporization, and of course this is melting. But we're going to see that we can obtain the reverse processes by through perhaps a fusion of this or cooling, and then we're going to have this one also perhaps involved in the process of freezing. So in this particular case, we can be able to consider these reverse processes in this particular case, or perhaps the process of fusion and vaporization, which we have in this particular case mentioned. And as we said, there's going to be involvement of heat. Therefore, we're going to see that the change of phase, as we said, is going to occur under constant a particular temperature. And therefore, we can be able to give an illustration or perhaps a representation for entropy using this specific a concept of the heat energy that is either taken up under constant pressure, which is going to be equivalent to the enthalpy of fusion. Now, we have already been mentioning the concept of enthalpy in our various discussions. Therefore, this is going to be the ratio between delta H R over T, which is going to represent the concept of entropy. So for a transition which is involving the concept of fusion, therefore, we are going to have the entropy of fusion given in this, for fusion given in this specific representation. And therefore, we're going to have the enthalpy of fusion given in that specific case, whereby this specific numerator is going to represent the enthalpy of fusion. And then we're going to have this one having the freezing temperature given as such. So therefore, we can be able to represent the change in entropy in this specific change of phase using this particular representation. So if you try to consider the case of vaporization, which is a change from liquid to gas, so this is going to be another phase change which is going to of course be taking place. Therefore, we can be able to represent as well the entropy of vaporization using that subscript delta SV, and therefore this is going to be the ratio between the enthalpy of vaporization all over at the temperature T. And in this case, of course, this is going to be the boiling temperature under consideration of this specific phase change of a substance that we're going to consider. So therefore, these are the ratios that we can be able to use in representing the various changes in entropy accompanying various phases. And as we're going to see that in most of these processes, there's going to be accompaniment of absorption of heat. And of course, the reverse is going to be true for these various processes that I've mentioned. Of course, we are going to see that the entropies of a transition is going to be the enthalpy of that specific substance divided by the transition, the enthalpy of that specific transition divided by the transition temperature. As we have said that for the process of fusion, we're going to have these specific respective temperatures for fusion and the boiling being given in this specific order. Therefore, we can be able to give a general illustration for the enthalpy change accompanying a phase change, whereby we're going to have the entropy represented as delta S, whereby the delta S subscript T is going to refer, where T implies a transition, which is a phase change. The enthalpy of a transition given as such 1 over the temperature of a transition. So whereby in this particular case, the transition is going to refer to various processes which are going to occur in order to, of course, or which are going to describe this specific concept of a phase change. Now, I hope that this is going to be elaborate for us. In order for us to represent the phase change, then therefore we're going to use these specific ratios, taking note of this particular transition that is going to be involved in this particular case. So check our description boxes for various links of other videos, and of course we're going to have practical questions which we're going to do from these specific concepts and try to see whether these various formula that we're coming up with are going to be of assistance for us. So that is it for now, guys. Bye. Catch us in our next video. God bless you.